Welcome, everybody. We come back to Chapter 6 Memory Assembly example for Model 6.3 and 6.4. And 6.3 section talks about using other resources. We're trying to seize and release resources in a different server. And Chapter 6.4 talks about processing time as a function of the queue size. And this is pretty fairly useful for basically labor type of processing. So the worker actually work faster if there are more items in the queue. Let's start with 6.3. We're going to add a secondary resource. We're going to call this fixture. So we need a fixture for the assembly process. So I'm going to call fixtures. Actually, I'm going to intend it to have 10 of those available for the whole process. And what I need to do is before we start doing board assembly, I need to grab a fixture, and then the fixtures move on with the chips, okay? With the assembly product, go to the packer. After the packer is done, then I can release this fixture, just get off the fixture and ship it out. So what do we do is, once we have this resource, we're going to go to the secondary resource, as we did it in the doctor's emergency room section. Okay. Other resource, here I have three things. I have for processing, meaning for the secondary resource, during the process, I may need a secondary resource. Okay. And also on the other resources C's, so before or after the process, we may actually trying to grab other resources. And other resources release, maybe during these process, we can release some of the resources for that. So in our application, what we do is before the process, we're going to grab the fixture for now, and the quantity equals to 1. Okay. And then for each one of the packing station, we're going to release after, okay, release the resource after the process is done. So I'm going to do this over after processing. Okay, do it one more time. So for the packer, secondary resource, release after process, going to release that worker. We're going to show you much more convenient way to do this, but now this is we show you how to seize and release resources in different station. So we're going to release after the processing and the fixture. So this is pretty much what we need for the, get it running a little bit faster so you can see. Okay, so you see this resource getting busy. I want to see how many fixtures are using currently. So what I do is click on the resource. Okay. One more time, click on the resource, choose the status label as we done it before for other places. What do I do is here is capacity and then utilize. Okay. How many of the resources utilized? And let's run this again. You can see that multiple resources are utilized during the process. So we grab the fixtures in the combiner, but release the fixture after the packing station is done. This is pretty much 6.3, Next, we're going to try to say if the Packer 1 and worker, and they decide their processing efficiency based on number of parts in the queue. So I need to come up with a discrete type of process. So that especially human laborers, and they usually, if there's nothing waiting in a queue, they kind of working slowly. But once there are parts waiting in the queue to be processed, they gradually increase their speed. So let's see how we do this. So first, we're going to go to a data section, create a lookup table. I'm going to create a lookup table, and we're going to call this lookup table call efficiency. Okay, lookup table efficiency, and X and Y. If the Q is 0, I'm going to have only have 80% of the efficiency. If I have 1 in a Q, I'm going to increase to 90% of efficiency. If there are two or more in the queue, I'm going to have 1, and maybe to the infinity, more than 100 will stay with the 1. And this is pretty much what I'm trying to say is if there's only 0 in the queue and probably just 80% of efficiency, 1 in the queue, I'm slightly increase my efficiency by 90%. But if there are 2, up to 2 in the queue, I'm going to doing full speed. Okay, these are the lookup table. But we cannot, how do we use this lookup table? We're going to using a function definition. Click on the definition tab, and then we go to the function. I'm going to add a function called function efficiency. Okay, for example. And this functional efficiency, we're going to rely on this process. So I'm going to using lookup efficiency. Okay. I'm trying to do is see how many actually in the queue. So I'm going to do server packer 1. Okay. Input buffer M content, input buffer's content, and number of waiting in the input buffer. So this is using server packer, which is specified as server, and input buffer content and number of waiting in that input buffer. So here, all right. Oh, sorry. And have one more thing. Need to delete. Okay, so this transfer, I'm going to using lookup efficiency table and using the number of waiting as an index to referring to this lookup table. All right. Okay, so here, nothing. How do we use these things in our model? So here we have a functional efficiency over the server packer 1. Okay, we're going to, this is a processing time. So I'm going to divide this processing time by the functional efficiency we have. I'm sorry. Okay, functional efficiency, what I have. The reason is why we're using divide instead of a multiply. And you could, as you can see here, we have a processing time. If we're using multiply, actually the processing time will be 80% of the processing time, 90% of processing time, 100% of processing time. Actually reduce the processing time. So I using divide, the efficiency actually will prolong the processing time, triangular distribution 3A5. And so it's actually longer of is 1 over 80% or 1 over 90% and so on and so forth. So this is what we have in the 6.4. And then we're trying to see if we can visualize this thing. I'm going to do the animations right here using a status plot over here. Okay. And kind of put it over here. I'm going to call this title. Efficiency plot. Okay. And X value will be the time, and Y value will be efficiency. Okay. And next, I'm going to give it 2.8. So it's larger. You can see a little bit better. Okay. So here I'm going to try to represent this. And I'm just going to plot the function efficiency. Okay. Over here. And I'm going to call it over here. Also, I can add, okay, for example, add more over here actually is server packer 1. Again, input buffer, content, number of waiting in there. So I'm going to call it queue size. Oh, queue length. How about that? All right, so we have two things. And this process probably getting an hour. It should be enough. I'm going to enlarge this so you can see a little bit better. And you can see the queue size, currently queue size and pack in front of a packer 1 equals to 0. So the efficiency stays at 80%. Okay. And keep going forward. I'm going to make it run a little bit more faster. Probably 35. So now you can see actually when the queue sizes jump and the efficiency also jump accordingly. Okay, this pretty much concludes the section 6.4, and we come back for 6.5.